Hello, right, this one is about calculating the frequency. We're still using a 555 timer, but this time we're using it as an astable timer rather than the monostable. So with the monostable, we used T equals C times R, and it worked out the amount of time that the actual output was on for, and then it went off. With this one, as an astable, the output goes on and off continually. It doesn't stay in a stable state. That's why it's called astable. So it comes on and off in a frequency. Now, the thing to do is, we've got a resistor here, we've got a resistor here, and we've got a capacitor at the bottom. Pin 7 joins between the two resistors, and it always does that. Pin 2 goes to the capacitor, and it always does that. And pin 6 joins to pin 2. Now pin 6 is the threshold pin which connects to pin 2, which is the trigger pin. So in effect it actually gets to a certain voltage and then keeps re-triggering. So it gets to a certain voltage, it keeps re-triggering. So that's why the output goes on and off. Pin 3 is still a resistor and an LED, and we've got to work out the amount of time, or the frequency, the rate at which that LED goes on and off, or it could be a buzzer going on and off. Right, the formula we use, frequency, is equal to 1.44 divided by brackets R1 plus 2 lots of R2 times by C. Now forget that stuff. You've got a resistor times by a capacitor. That's the same as the T equals C times R side of things, so you'll be familiar with that when we come to that. But when we've done that calculation, we've got to divide it into 1.44. That's really all there is to it. So we need to make sure they've got values on. So if this is 1K and this is 10K and this is 10 microfarads. So those are all given to you in the question one way or the other. They'll be on the circuit diagram or they'll be written at the side. So that's what we need to do now. So we've got to use the formula F equals 1.44 over brackets R1 plus 2 lots of R2 times by C. So substituting in that, remember you get a mark for that if you can substitute in the values. 1.44 divided by R1. I'm looking at this. R1 was 1K and R2 is 10K. Remember, this is always the position of R1, that's always the position of R2, and that's always the position of C. So R1 is 1K plus 2 lots of R2, which is 10K, so it's 2 lots of 2 times 10K, brackets C. Now doing the calculation, 1.44. We've got 1K plus 2 lots of 10K, so that's 21K, so that's 21K times by C. That's the bracket done. The 1K plus 2 lots of 10K gives us 21K times by C. So this is just the T equals C times R. So we do this as a separate little thing. So we've got 21 times 10 to the 3 times by, and C, remember, is 10 microfarads, 10 microfarads. So it's 21 times 10 to the 3 times by 10, which is that, times 10 to the minus 6. Remember, because microfarad is minus 6. So that's that worked out there. We've got powers again. That cancels with that. So we've got 21 times by 10 times by 10 to the minus 3. Because minus 6 and plus 3 leaves us with minus 3. We have to add the powers together, and that's what's left of the power calculation, minus 3. So we've got 21 times 10, that's 210 times by 10 to the minus 3, which is the same as saying That's 1,000th. Minus 3 is 1,000th. So we could say 210 divided by 1,000. If we cancel that with that, we've got 21 divided by 100. So the calculator is here. Sorry about that delay. So we've got 21 divided by 100 equals that. That's 0.21. So we've now got 1.44 divided by 0.21. The 0.21 is that bit there. So all of that calculation there, this bottom here, allows us to come up with 0.21, and that goes back into the formula. So the total frequency calculation, to clear that, is 1.44 divided by 0.21 is equal to 6.86 Hertz. Frequency in Hertz, that means it flashes at 6.86 times a second. 1 Hertz is 1 flash per second. That's the calculation. I'll go through that again with you, just to make sure that you're okay. So we've got this layout. This is the standard layout. That is always R1, that is always R2.